Dear friends, today we are going to discuss very important concept, that is black body. So, what is black body? It is an ideal body that absorbs all incident electromagnetic waves or radiation regardless of the angle of incidence or frequency. As it absorbs all colors of light, it is named as black body. There are some black body radiators. These are the examples of some black body radiators you can see. These are stoves, electric heaters, the stars and sun, then incandescent light bulbs, warm-blooded animal, burglar alarm. These are the examples of black body radiators. Then you can see a graph that is plotted uh, radiation intensity versus wavelength. So this is the radiation intensity of black body, and this is corresponding wavelength. Now there are three, four curves. Here you can see the curves are drawn at different temperature. First curve, this is taken at 500 Kelvin, 5000, sorry. First curve is taken at 5000 Kelvin, second at 4000 Kelvin, then third 3000 Kelvin and 2000 Kelvin. Now you can see at a given temperature, the peak of this is intensity axis. So peak of intensity is obtained at shorter wavelength. Okay. So we can say the peak is shifted towards the origin, means at shorter wavelength, we can get the peak of radiation. So this peak basically lies in visible region. Visible region means wavelength should be in between 380 to 700 nanometer, and before that this is ultraviolet region, and after that this is infrared region. And this is the law which helps to explain this spectrum of black body radiation, that is Wen's displacement law. So in this graph, the x-axis on the graph shows the wavelength, while y-axis shows the corresponding intensity for that wavelength. Now, this is Wen's displacement law, which helps to explain black body radiation. Now, according to Wen's displacement law, the black body radiation curve for different temperature peaks at a wavelength is inversely proportional to the temperature. As you can see from this expression, we can observe a peak at shorter wavelength, and corresponding temperature is highest. Yes, you can see 5000, 4000, 3000, 2000, and so on. Now, what is fairy black body? So this is an example. This is a diagram of fairy black body, and this is very important. This is ideal approximation, or we can say approximation of ideal black body. So a ray is sent in this cavity, and here it is reflector, and after reflection from here, it suffers again multiple reflection inside the cavity, and only 2% of the incident uh, radiation can go outside. This is almost 2% goes out the cavity, and 98% remains inside. So we can say this absorb almost all the incident radiation on it. So a cavity with wall made of any material with a small opening is an excellent black body. This is fairy black body. It is also absorb all electromagnetic radiation incident on it, irrespective of the wavelength. Okay. So a perfect black body radiates all the heat that it absorbs. Every body absorbs some heat falling on it, and also radiates heat to the surroundings. A hypothetical black body that absorbs all the heat falling on it is called perfect black body. Means if a body absorbs all the radiation or heat falling on it, then it is called perfectly black body. So a black body also is a perfect emitter of light over all wavelength, but there is one wavelength at which its emission of radiation has maximum intensity. So we can see from this graph, at a particular wavelength, the radiation intensity is maximum. Yes, and very important, hotter object emit more radiation than colder object over all wavelength. And one important thing you have to note, black body is a good absorber as well as good emitter. This is very important property of black body. Black body have good absorbing power as well as good emitting power. So I hope this will help you to clear the concept of black body. Okay, thanks for watching.